All right, so chapter 15, probability rules. All right, so we had an addition rule and a multiplication rule in the chapter 14 notes, but now we're going to have a slightly modified version of those. For the moment, we're going to have the general addition rule. So this is the probability of A union, which we remember means or, B is equal to the probability of A plus the probability of B minus the probability of A intersect B. So this is the intersected area. I'll draw a picture of it in a second. Intersected area that gets counted twice, technically. It gets counted 2 times, so we need to subtract it once.
So why do we learn one addition rule and then change it?
They're for 2 different things. Remember the other one was for disjoint or mutually exclusive?
That, yes.
In case anybody's wondering, Brooke and Taylor are here to ask questions for anybody else, because, you know, I may not catch what those questions are, so. Oh, that is not a circle.
The video is just going to be Brooke laughing.
No.
So we've got A, B, and then this area in the middle is A intersect B, which because it's overlapping, we would technically be counting that spot twice when we only need to count it once. So that's where we're subtracting it off. All right, so we're going to look at a little example with this because it's probably the easiest way to understand this material. So we're going to look at a Venn diagram example. So in the textbook, okay, this is a made-up example. This is not actually true of our textbook. In the textbook, 48% of pages have data displayed. 27% had an equation, and 7% have both. We're going to really hope that adds up to 100, and if not, then just kidding, it won't add up. Never mind. Remember, there's pages that might not have either, which is the complement. So anyways, yeah, we're good.
What?
Okay. We'll get there in a second. I'm talking randomly. Okay, so we're going to look at the Venn diagram with this in terms of labeling things here. So I'm going to try to draw 2 big circles. Oh no, not outside.
I have a really dumb question. Why is it all in a rectangle?
Just showing the data area, because we're going to have the stuff that's outside of those.
Okay.
So remember, we may have pages that don't have data or an equation as well, which is going to account for the other percent that's missing from 100, basically.
That makes sense.
Well, I shouldn't say percentages. I told you yesterday that they're not percentages, that they're decimals. I should say from 1, the stuff that's left over, technically. So this area, the box is representing all pages. This thing is spazzing on me. All right, so that's all pages. 1 circle is going to represent data. And I'm going to use different colors just to help see. The other one is going to be for equations. And then the middle area here is going to be for both. So for the data, we're told, or we're going to look at the pages with data and no equation. So 48% have data. But we said 7% have both, so we need to remove that 7% from the 48. Okay, so in reality, I should actually make this a decimal. So 0.48 minus 0.07. So we're getting rid of the stuff that had both. So there's data and no equation here that we're looking at is going to be 0.41. And that's what's going in this left circle.
Whoa.
There we go. It's getting a little blurry.
Is that gonna do that?
Huh?
No,
Is
in the
that
video,
really-
no.
in the
No, I
video?
did that up here.
So they won't know why I just made that reaction?
Correct.
Ah.
Let's see if the probability.
So then we're going to have pages with equations but no data. So this time it's going to be had an equation, so 0.27, minus the ones that have both, so 0.07, so 0.20. I'm realizing I should have changed technically colors when I wrote both up here, so that everything is clearly labeled.
Oh, I'm ignorant for my both too.
So then pages with equations or data. So we're looking at the probability of equations, union, data. Okay, but since there's overlap, we've got to remove that. So it's going to be the probability of equations plus the probability of data minus the probability of both. Okay, and technically I actually should have put this 0.07 in here. We already knew that. I don't know why I didn't write that. We knew that because that was given to us. We could have put that from the beginning. So the probability of equations was 0.27. The probability of data is 0.48. Minus the probability of both was 0.07, which is going to give us 0.68. So that's the total area taken up in those circles. And technically, we could have gone and we could have added together these numbers up here that we had already gotten, but this is just another way to show how you get it. If you added the blue and the red with the green 0.07, you would get 0.68. But this is the official formula that you'll use that'll make your life easier with bigger problems and stuff. So then now, the stuff that's going outside. So then the pages without equations or data, so the pages that have nothing. So it's going to be the complement. So this is going to be 1 minus the probability of an equation, union data. So this is 1 minus the probability that we found up here in the lime green. So 1 minus 0.68 is equal to 0.32. So 0.32 is what goes up here outside the box as everything that's left over. So the pages that don't have data or an equation. All right, now we're gonna throw it back to contingency tables. Or conditional probability. So remember, contingency tables showed relative frequency
Isn't that the percent one?
and conditional distributions. So then now we're going to have a conditional probability which calculates the probability of an event occurring given a condition has also occurred. So a hypothetical example for this week would be something like the probability that school gets canceled given that it snowed. Or the probability that school gets canceled given that people are sick.
It happened.
It has happened. So, formula for this is the probability of B, and then it's one of those, it's on your keyboard technically, but it's like a really tall, like, up and down line. It's like, I usually call like an absolute value bar. It's just like one of them instead of like, two of them. Just goes between. So it's the probability of B given A. So I'll write that in words. So the probability of B given that A has occurred. So these are ones that you really have to look at wording, because if it was switched, it'd be the probability of A given that B has occurred, and so it can really like throw things off. So it's important to pay attention to what order it's asking, or else you'll get it wrong. Sometimes problems will ask you for multiple things. So then the actual formula, the probability of B given A is equal to the probability of A intersect B, so A and B, over the probability of A. So a lot of times when I get to like a test or a quiz, or I'm like grading one of y'all's like tests or quizzes or something, or like making the key for it, what I'll do is I'll convert whatever I'm given into this and then write it looking at it from this perspective, so that I make sure I do things in the same order. So like if like, not that you're going to be doing it with letters, but I'll make sure that I do everything in the same order, and I'll write this formula down every single time because it just like helps. So we can look at an example of this one too. So we're going to make a table with 5 columns, 4 rows.
make the line straight now. It's okay.
So we're going to have goals. We're going to have grades. We're going to have popular.
That's me.
We're going to have sports. And then we're going to have totals. Then going down, we're going to have boy. We're going to have girl. And then we're going to have totals. And then going across, starting with boy and going all the way across, 117, 50, 60, 227. Girl, 130, 91, 30, 251. Totals, 247, 141, 90, 478. And I will say a lot of times when you do a problem, they're actually going to ask you to find each of these individual pieces and then turn around and find the conditional probability. So it'll tell you, like, find the probability of A. Find the probability of A intersect B.
That's disgusting.
And then it'll say, find your conditional probability. So you've actually already done all the pieces. But that also means that if you use those numbers and one of those was wrong, but you have them in the right places, I'm a little bit more flexible with, like, your answer. If you had the right process, you used the wrong numbers or something, then I'm a little bit more lenient with that too. So it might ask you for something like general probabilities first. So it may ask you for the probability of it being a girl. So the probability that it's a girl is the total number of girls, which is 251, divided by the total number of people, which is 478, and that would give you 0.525. Then it's possible it may ask you something like the probability of sports, which would be the total in sports, so the 90, divided by the total altogether is 478, which is going to be 0.188. Then it may say, how about the probability of a girl intersect popular? So a girl and popular. So we're looking in the column that fits both of those. So popular, girl, that's 91. So 91 out of still the total, 478, is 0.190. And let's just make a rule 3 decimal places for all of this stuff just to make it easy. So then, if we include, so we're going to continue this example here. If we include the condition that the student is a girl, we are dealing with conditional probability. So if you were to have something like the probability of sports given a girl, okay, and these are things that they want to excel at, so that's what when it says goals, they're wanting to excel at grades, being popular sports, okay, things like that. So the probability that they want to excel at sports, given that they are a girl, so let me write this out. So this means what is the probability that a student wants to excel in sports given that they are a girl? So this is the probability of sports given that they are a girl. So again, I like to actually rewrite, okay, this formula here every time so that I make sure I follow the example exactly. So the probability of B given A was equal to the probability of A intersect B over the probability of A. So then I'll actually use my words that I'm using here to fit this exact pattern. So I would rewrite this then as the probability of sports. Actually, I want to follow exactly. So B is the second thing that's listed. Or sorry, B is the first thing that's listed. So it's going to be, this is backwards because it's A and B. It really doesn't matter, but I like to try to follow it. So the probability of a girl intersect with sports. Okay, that way I keep my A and B in the same spot. And that way I also keep the fact that the A that's going on the bottom is whatever the first thing is listed. So over the probability of it being a girl. So then the probability of a girl intersected with sports, so we're looking at the column. So girl and sports is going to be this 30 here. Out of the total number of girls that there are. So girls total is 251. And for some reason I actually don't have that decimal, so let me, 30 divided by 251 is 0.120. So then if we were to flip this to have, instead of the probability of sports given a girl, if we wanted to flip it and do the probability of a girl given they excel in sports, this would be written as the probability a student is a girl who wants to excel in sports. So now we have P of girl given sports so again, following this pattern, okay, so it's the probability of sports intersected with being a girl over, now instead of the probability of it being a girl like it was in the last one, it's now the probability of sports. So the intersection, like I said, it doesn't matter. I don't know why, but sports looks like it's spelled funny now that I've written it so many times. The intersection, it doesn't matter which one comes first. So I could write girl intersect sports or sports intersect girl. That number's the same either way. Okay, so that's still the 30. But now the probability of sports, I need the total in sports. So I can go back up. In sports, I come down. The total is 90. So now it's 30 over 90, which is 1/3 or 0.33. I guess I could say 0.33 if I want to get technical since I said 3 decimal places. So those are conditional probabilities, and those are one of those things that, it just comes with time. A lot of this unit will just come with time. The more you do it, the more you see the words and stuff, it'll just like make more sense. So we had our general addition rule. That was what we did to start out these notes. Now we're going to get the general multiplication rule. And something just to note is that this does not require independence. Oh no, I think my pencil died.
Oh dear.
This could be a minor problem if that happened. It's dead. So it doesn't require independence, so I'll just talk while this charges for a minute. So basically, yesterday in your video, I talked about how they had to be like independent conditions that like hitting the red light today did not mean you're going to hit the red light tomorrow, or hitting it green today doesn't mean that you're going to get red tomorrow. One day doesn't affect the next. So those were independent, but this one does not require that, and it's in light of this new rule. I don't know if this is actually charging. Okay, we'll see if it'll give me a little bit. Probability of A intersect B, so A and B, is equal to, and there's going to be 2 different possibilities for how this can be written. The probability of A times the probability of B given A. Okay, so this is using that conditional probability. Or the probability of A intersect B is equal to the probability of B times the probability of A given B. So you now have the conditional probabilities playing a factor in this, which is why we did the conditional probabilities before we actually went to the general multiplication rule, because if not, you would have been confused. Okay? So you could also rewrite the probability of B given A, using wherever it went. This formula here. If you wanted to rewrite it that way, you could. Ultimately that's what you're doing, but if you know what the formula is, you don't necessarily have to write it that way. You can just get away with it being written like this. All right, so we'll refresh briefly on independence here and what that means. I'm gonna find a new color. I'm using the same colors over and over again. Just need to mix it up. Okay. All right, so independence. So recall that independence means that the outcome of one event does not influence, oh no. This has got 12%. It can't be dead. Hello? Does not influence. It's apparently having a mind of its own today. The outcome of another.
Did you drop it on the floor at all?
No. Not today. So then, a more formal definition of this. Events A and B are independent. That's not the formal definition. We would write it like if the probability of A is equal to the probability of A given B, that would show independence. So if I tell you to show me they are independent, this is what I'm looking for. Because this would say that the probability of A given B does not change what the probability of A is. A doesn't change if it happens based on whatever happened with B. So we'll look at an example of this, just a couple different things. We'll still use the chart from up here, so I'll have to keep scrolling back to it to prove independence or not independence, as the case may be. We'll look at two of those. Orange. So, a couple examples of this. Number one is having good grades independent of gender. So to check it, we would do the probability of grades given that it's a girl is equal to the probability of grades. Okay, so that would say that being a girl shouldn't change the probability of grades happening, basically. So,
Whoa. Did you hear that? Am I losing it? What is that?
the air conditioner.
In winter?
Well, just the like the fan for the air conditioner / heater.
Oh, I thought you meant like actually it's gonna get cold in winter.
All right, so remember, okay, our condition here. We're really looking at the probability of being a girl intersected with grades over the probability of it being a girl. Okay, and if that's equal to the probability of grades, then they are independent. So, girl intersect grades. If we go back up and we look at it, girl intersected with grades is 130 out of, what did I say, the probability of it being a girl? Yeah. So, 130 out of 251, so that's the total number of girls, is equal to the probability of grades. Sorry. It's a problem because I don't have the table in front of me. Probability of grades is going to be the total in grades out of the total number of people, so 247 out of 478. And what you would find if you actually did these on your calculator is this is 0.52 is equal to 0.52, meaning that grades are independent of gender. Now again, this is one of those things where if they're really close, like 0.53 and 0.52, you can probably say that. I mean, technically they are supposed to actually be equal. Really, if the first two decimal places are the same, then that's what you're looking for. If the third one's a little bit off, like if it goes out to 3 decimal places, then that's fine. But they should basically be the same thing. So then another example of this is sports, independent of gender. So this time we'll do the probability of sports given that it's a boy is equal to the probability of sports. Okay, because we want to know if sports is independent of gender, so we're ultimately looking at sports. Okay. So with this one, you've got your probability of a boy intersected with sports divided by your probability of it being a boy equal to your probability of sports so just so I don't have to scroll all the way back up, let me go back to my paper where I wrote these down.
That's a good idea.
Be a little easier instead of me scrolling back up. Y'all can go back up and find it yourself in your notes. The probability of boy intersected with sports is 60 over the total number of boys is 227 equal to the probability of sports, so the total in sports out of the total number. So 90 out of 478. So these actually come out to be 0.264 and 0.188.
So they're not
But
independent.
these are not equal, so sports are not independent of gender.
What does that mean?
So excelling in sports is not affected by gender,
Okay.
basically.
So the equal ones meant they are independent, which means gender did matter.
Or sorry, independent
versa?
means it doesn't matter.
Okay.
If it's not independent, then it does matter. I always say those backwards, even though I, know what they are. So then, something else to note with the independence stuff is that independent does not equal disjoint. Okay, or mutually exclusive. If events are mutually exclusive, they can't be independent. Hey, Maddie. Are you joining us?
No. Yeah. That's really awkward.
Bye,
We'll
Maddie.
be on the video later.
Are you joining us? No.
No.
She and Miss Patton, I guess.
What?
Yeah.
Chemistry.
She was. Oh.
And yeah, I'm gonna go to Miss Patton after this and be like,
Actually,
I should
gonna
go to
Mrs.
chemistry after
Marshall
this.
And then I'm gonna go to Mrs.
Yeah.
So use probabilities.
I want you to know, like, this makes almost no sense to my head.
It's one of those that it definitely takes a lot more like seeing examples. That's why I'm trying to do like a little example of each so you have a little bit of a knowledge of it, so then when we get to the examples like in the packet, it won't be like Greek to you.
It's gonna be like, she said like 6 pages.
Another page.
1 page?
Well, this page and then another page, so like
Oh.
about a page and a half.
We're zipping through this. Look at us champions.
So use probabilities to complete a contingency table.
Complete, not compete.
Identify if given data represents conditional or marginal probability.
Yep, totally understand.
So this part I will say is probably slightly more confusing than the other stuff, just in the sense of how you write it up.
Slightly?
Not harder, just a little bit more confusing. I don't want to like scare you. It's not hard. It's just basically in the other one you were given the table, we got the information. Now you're given some information and we're going to create a table,
Oh.
essentially.
Ew.
Not in its entirety, but it's kind of what's happening.
That's gross. Well, it makes me sad. I want a big smile. Wait, frown.
Big smile for Brooke. When stopping people for suspected DUI.
Wow, we're going here today.
I hope none of you ever get one of these. 78% of suspected drivers.
Oh. Sorry, I switched to eraser.
Oh, mine does it all the time. It's very annoying. Get a breath test. 36% a blood test.
Ew, I don't like blood.
And then 22% get both.
It must be really messed up to get both.
Well, it's more of the both is more one of those where maybe one of them didn't read that you were drunk and the other one would, so you probably get both if they really think you are.
Are you wearing the new leggings?
Mm-hmm. Thanks.
I wore new leggings, but I
should have worn
I grabbed my pajama sweatshirt and said, works for me. I didn't wear my pajama sweatpants today.
If I don't actually have to be at school, I'm going to be comfortable.
Oh, I
That's
agree.
my opinion.
Who's going to tell you can't even wear that to school?
You never know. All right, so then just something to note here before we actually go and start putting stuff into a table. 78% and 36% are totals. Okay, meaning marginal distributions, or marginal distributions are totals.
How'd you know that?
Because basically this is telling me that 78% got a breath test, which is of all the people that were pulled over got a breath test.
I get it.
36% of all the people pulled over got a blood test. So that's going to be the total amount in each of those columns.
That makes sense.
But then the people that get both, you're subtracting out of those in a sense to get,
Ouch.
yeah.
I got the first two.
So then 22% is a joint distribution, which we're going to use to find the other stuff. All right, so what I'm going to do, we're going to make a little table. I'm going to do everything we know and we were given in one color and the stuff that we're going to find in another color. So sometimes they will set up a table for you with stuff already filled in and you have to fill in what's missing. Sometimes you have to completely make it yourself. So I'm going to do this one as if we're making it ourselves because obviously that's a little harder than if I just give it to you. So I'm like running out of like color ideas and this is really a problem. Okay. All right, so what we're going to do is we're going to set up a little table here. So in these outer areas, okay, this top little corner here that's, got nothing in it is going to continue to have nothing in it. Y is going to represent yes, surprise. N is going to represent no, also a surprise.
What? Oh my goodness.
And then out here we're going to have the total.
I can tell you what total stands for.
Then on the left we're going to have a Y for yes. An N for no. I didn't make my table big enough, so we're going to
Aww.
go a little farther.
My table looks gorgeous.
There we go. And then down here we're also going to have totals.
Don't brag, bro.
Okay. So on the left side, doesn't matter which left or top gets which one, but
Isn't there only one left?
like left or top, it doesn't matter which one gets which label. One's getting breath, one's getting blood. I'm doing blood on the left and breath on the top.
I don't ever leave enough room for little side things.
I know, I always forget to.
Oh, yeah.
You can always just draw a little arrow to where it's going.
I'm gonna do that.
Just draw a red dot and that's blood.
So what this table set up, okay, the reason it looks like this with the yes and no on the top and the yes and no on the left, okay, if they got a breath test, then they get a yes in that column. So if they only got a breath test, then that's going in the yes but no. Okay? We're going to do it in a second with that. I'm just giving a rough explanation. If they get both, it's a yes and a yes. Okay? There's obviously, it's got to add up to be a certain total. So if somebody didn't get any of them, if they pulled them over and then they were just like swerving just because, they're being a teenager and they're not drunk or whatever, something like that, then they didn't get either test, and that's going to go in the no and no column. They didn't get either. Okay? So the things that we know, we said we know totals. So we know 78% got a breath test. So that means in the yes column, okay, the total in the yes column for breath, so that's coming to the top Y and going down, is going to be 0.78. So that was a given value. So all my given values are going to be in this deep purple. Okay. The other total I was given was 36% got a blood test. So that's going to be a yes in the blood column. So the Y on the left side, go all the way over to the total. 0.36, okay, gets a blood test.
Oh, that's not a 3.
So then the joint distribution where they got both was 22%. Okay, so that's going to be in the yes and the yes. They got both, so it's a yes for blood, yes for breath.
The little
So
corner at the top, right?
this one, oh no, did we die again? We died again. That's going to be 0.22.
You're going to have to start writing with your finger now.
I know, it's not good. It's not pretty when I write with my finger, though. It's really bad.
Alrighty, I'm ready. I'm excited.
Not awful.
I was gonna say, why does that not actually look that bad? Mine looks worse when I'm using the pencil. That's embarrassing for me.
Okay, so those were the only 3 numbers we were given. But what do we know about the ultimate total that happens over here in the bottom right corner?
100.
Okay, 100%, or what is a decimal?
Point something.
Wait, 100% you said?
100%, yep, 1. So just to keep with the decimal points, oh gosh, 1. Okay, this bottom corner is always, I need to rewrite this. This is bad. That's bad.
Oh, it's not that.
It's bad. Let's call it what it is.
It's
It's 1, and this is always going to be 1.
Wow, your arrow looked better the first time.
That is true. There.
How do you make the arrow do that? Like, isn't there a fancy way for the arrow? Like, like the
Yeah,
little...
you just push and hold.
Wait, what did you do?
You know how I do the circle and you just like push and hold and you just let it do it? Well, I made an oval yet again. But you just go up, and this is one motion, you make your, one motion, you make your arrow. And then you just hold it. All right, so those are all things that we knew. So now we need to find everything else. Okay?
Hold on, I have an idea.
Oh, I forgot I turned on draw with finger. Come on. Hello.
Wait,
And
we dead again?
And we're dead.
I hope people have a kick out of this.
I hope so too.
And we're dead.
All right, I'm going to go to green to do the other stuff. So let me just walk through what's going to happen here, and then we'll actually show it. And I just wrote with my finger again because I still have draw with finger on. We're going to turn that off because that's going to keep happening. All right, so in the columns that are left over, that's stuff that we don't know, right? So I've got to take that joint distribution from my totals, okay? And to do that, I'm just going to simply subtract. I'm subtracting off so that I get the people that only got, for example, this, well, you can't. Now I can't do it. Okay, this spot where it's the yes for breath, no for blood, okay? What that's going to be is that we're taking the total number that got breath and we're subtracting off the ones who also got blood.
So it's 0.78 minus 0.22.
Yep, so that number is going in that column.
Are you going to do the math? Or?
So 0.78 minus 0.22. going to be 0.56. So that's going here.
Good job, guys. We're so good at this.
So then we're going to do the same thing in the other column. So the yes for blood, no for breath. So that would be 36 or 0.36 minus 0.22.
This is kind of fun. It's like a puzzle.
0.36
okay.
minus 0.22 is equal to 0.14.
You don't want to say it's fun because then we're going to get a bunch of them. Isn't that how teachers work?
Sometimes.
Or you say, oh, I hate this. And they're like, here's 25 of them. That's evil.
So now we need to add up the stuff and figure out how many didn't get any of it. Okay. So the best way to go about this, I would say, is with a Venn diagram.
Oh, never mind. It's not super fun now.
You know, it's actually a little fun on here because I get all perfect
Did
circles.
you say funner?
I said fun on here.
No. It was like,
Oh, look at your
oh
finger.
my God, look at
marks.
Mrs. Patton.
Alright, I'm ready for this.
Oh no, not a circle. Why can this thing not get when I want a circle versus an oval?
Oh, I have one giant circle and one baby circle.
Yeah, I kind of do too. I'm not gonna lie.
No, mine did not look like that. Mine was like the circle outside of the box.
Okay, so we're gonna do blood in one, breath in the other. So blood, breath,
This is a really creepy lesson.
both. So where they got both is in the middle, which is 0.22. That was given to us. Okay. So then for the blood, we want blood, not breath, which is going to be yes for blood, no for breath. So that's going to be 0.14.
You know what this reminds me of? That really weird. Remember that one at the beginning of the year when we had that rain question that was like, yes, it rained, no, it rained. It was like you did. It's just like that, and it confuses me just as much as that one did.
And then for breath, we're going to have yes for breath, no for blood.
Okay,
So that's going to
the
be,
0.56, right?
yep, 0.56.
Look at me, I'm catching on.
So now what we're going to do is we're going to add up those and then subtract them from 1 because we're trying to find the complement. We're trying to find everything that's left over. So 1 minus 0.14 minus 0.22 minus 0.56 is really what's happening.
That's why it's minus 1.
1 minus, yeah.
I get it now.
So then everything left out here is 0.08. That's what this would come out to be. So then in the no column, 0.08. And then the other two totals that you didn't have written here are just your 0.64 is what's going right on the right-hand column. So we got 0.64, and then down here, this is going to be 0.22.
Oh, and you did that by subtracting the thingies and whatnot.
I added these across. So the 0.56 plus 0.08, and then 0.14 plus 0.08.
Nice.
So I filled in the table, and I've answered all the questions that they wanted me to answer.
You know, can I say something fast real fast? Wait, what?
Can I tell you something fast real fast? I don't know, can you?
Okay, this week for church, we're singing, how great is our God, great are your Lord, great I am, God is great. I have a feeling we're going with a theme here.
You never can tell.
I hope this is what Pastor Wilson's preaching on, or why are we doing...
You could always add God of the Ages.
I know, we did that one last week, though, so we can't sing it again. I love that one. That one's
too.
so much fun. All of them have God, something great, or great something God.
All right. Let's see.
Ready?
A lot of notes.
Yeah, it is a lot of notes.
It's more fun though when I did this at home yesterday with the log notes.
Ooh,
I
have a really
was
pretty
sad.
order I've been wanting to
I've got to say, I was really missing the background comments from everybody yesterday when I made
Me
this.
too. I was listening to this and was like, no offense, but this is kind of dull.
I know, right?
Did you just call her dull?
No, the fact that there was like no like.
There was nothing going on but me
Yeah.
talking, and it's like, you know how weird it is to teach to an empty room?
Ooh. Like when you sing like to an audience and like when you like a concert and there's no one there.
Yeah. All right, so we can also have a replacement or something where it's without replacement.
Oh, now you sound like science. I already know replacements and single replacements.
So
And
be
I don't know
aware,
which.
not beware, beware.
I think there's different colors of
Beware.
that.
Be aware
Nope, it's beware.
of conditional probabilities.
I wrote,
No,
no, but I split them. I was saying, now I have B splice.
Due to non-replacement
I can't do this anymore.
of possible outcomes.
I've already gotten dumb.
Think it through.
Thank you, I know, I'm trying.
So sometimes things that will help with this would be diagramming. So tree diagrams.
Oh my goodness, can we have a flower one too?
So we got our little.
Guess there's a
Wait, didn't there like the stem and leaf thing and Maddie said it was like an apple tree or something?
All right, so we've got
Wait,
our tree
really?
diagram.
Wait, is it like actually a tree?
No, I'm joking. I
Oh,
just
no,
felt
I
like
was-
drawing a tree.
I want to draw a tree now.
Tree diagrams show sequences.
I'm done.
Oh, my tree looks
We have another
good.
page of events.
Oh my.
It helps us
My tree
reason through
Oh.
the situation and calculate complicated probabilities.
Okay, if you have to say the word complicated, it's not good anymore.
It's very possible I spelled something wrong. Don't quote me on any of this.
Remember, she's a math.
We discussed that I'm very bad at spelling.
No, me too. Mrs. Patton.
And they tried to send me to the spelling bee.
Mrs. Patton told me you need to take. You know where your faults lie. You need to take advantage of spell check and grammar check. I was like, out. It's true though.
All right, so we're going to look at another example.
Blue.
And we're going to do, it's going to be a full page example, basically.
Then that's the end, right?
Yeah. There's technically one more teeny tiny little example at the bottom, but it's basically a whole page of this one example.
Got it. Let's go.
Or we're going to make a tree diagram that doesn't look like an actual tree.
That's so boring. Maybe what if I make? Can I just edit?
I guess in honor of Maddie, I could make this a little apple tree, right?
Oh, look at two little apples.
Don't mind, I don't take art class either, so nobody judge me.
I think if you see my tree looks. I mean, it's.
I didn't even have room for
Oh.
a tree.
Nice. Well, that's unfortunate.
Your tree is a
Stop.
All right.
I
So,
can't.
example, 44% of students binge drink. I notice this is a common theme.
Yeah, I think they're trying to call people out here.
We'll say binge drink coffee. Let's do
There we
that. 37% drink moderately.
Moderately drink coffee, guys.
The Christian version of this problem. And then 19% abstain from coffee.
They're anti-caffeine. Or they use tea, get the
That
switch
means they
caffeine.
can't
Guys, I haven't had
have
coffee
chocolate
in
in.
like 6 months.
No.
Oh, it's been a long time.
Yeah, like 4 weeks.
No.
Among binge drinkers of coffee.
I haven't had it since the one time.
Have coffee.
Mom and Dad went to Starbucks that first time. Now I've been getting tea ever since.
17% have been in a coffee-related accident.
They just got too hyper. They just kept pushing the gas.
And then alcohol. Ladies and gentlemen, this is what not to do. And non-bingers, not like the Avengers, but non-bingers,
Oh man, I put 3 C's in accident.
only 9% have, I guess, been in an accident that was not alcohol related. Or that they've, I guess technically non-bingers means they could drink moderately, or they could abstain.
So it's only been 9% of drinking accidents versus accidents.
Drinking accidents.
How can they be in a drinking accident if they don't drink? They abstain.
Well, it's saying 9% of non-bingers, which could either be moderate drinkers or no drinkers. So they
But also, like, the
just
other
in an
person-
accident, I guess, would technically be the way to put it.
Okay.
But alcohol related if they do drink moderately.
Coffee.
Don't drink the coffee in that car, guys.
All right, so I'm gonna make 2 little notes, and then we're gonna draw our tree. So
This should be a real tree.
2 little notes here. The first branch separates. Well, if this is a real tree, it's a tree that has fallen.
That's so dry. Why do we go there, guys?
By type of drinker.
Oh my word. I think I just
Love coffee.
So
I put
all possible outcomes will total up to 1.
separate I can't do this anymore, guys.
Then, when we add in accidents, these numbers depend on drinking behavior.
Like binge or moderately.
Yeah, or none.
I was gonna say maybe it's aggressive behavior. Or...
You're going to want a decent amount of room to make this tree, so don't just like cram it in like 3 lines for anybody writing on lined paper. It won't fit.
It's so nice not having to worry about that anymore. You just keep scrolling.
So we're going to have
I'm ready. It looks a lot like that one thing we did last chapter.
I think it looks more like a duck's foot than a tree, personally, but
It's like a dead tree.
well, it's gonna get some more branches on it in a minute,
Which way?
in a different
Do I have
color.
to leave any room on the side?
The left side, no, you don't need any room.
The duck diagram.
The duck diagram.
Oh, that was really bad.
I have in here, each set of branches adds to 1, so the other branch is. I think it's supposed to say branch. All right, so top one is going to be binge. And we're literally just putting in the numbers from up here. So 0.44. Moderate in the middle. It's 0.37.
Oh, that was also
And
bad.
again, these are all given. And then abstain was 0.19.
Why are there more drinkers than abstainers? That's a little sad. I'm embarrassed for those people. Too much coffee.
All right, so then off of each of these branches, we're going to have another set of branches.
Oh, eraser. Oh. It does look like a duck foot.
Or a chicken foot or something like that.
Oh no.
Don't
I have
mention
to redraw
chickens.
it. I
Chickens
didn't
are
leave enough
evil
room for the
creatures.
more branches.
My neighbor has chickens, and they keep going into our yard. It's so stupid.
My cousin has chickens.
Oh, they're yummy. You don't eat them, right? Do they make eggs?
But stop.
Yes to both.
Oh! Are they yummy? Fresh chicken, is it better? Like, does it taste different?
A little bit.
I was just wondering, you know, see the commercials.
Their rooster's name is Cornelius.
Oh,
That's kinda
And then their one of their hens is named Mamu.
That's actually
And
kind of
he's
cool.
really big and fluffy and white.
Aww.
With like the little red like gobbler thing. You know what I'm talking about? The
Yeah,
little
yeah,
goozle
yeah,
thing.
yeah. Hold up. Why does mine not look right?
I was like, how did we get on chickens? And I was like, oh yeah, because I said this kind of looks like a chicken foot.
Like, how did we get on this rabbit trail?
Bruh.
What?
That's how we got on it.
Bruh? Yeah.
So then each of these is going to have accident and none. And then we're going to look at the percentages of each.
Oh man, I should have not written. So big. Oh, you can't even tell what that says. That is way too small.
There better not be any more branches because I can't fit any more branches.
Wow, that was like.
I told you needed a lot of space.
Is there actually more branches?
No.
Yeah. Why? You just sit there and it just does that.
Just happened. I don't know.
Did you break it or something in the past, or does it just do that for funsies?
I think it just does it from 28 seasons of sports.
That does make sense. And then now you coach sports, so you're still doing sports stuff.
It's a fact.
Your girls played so hard. I feel sometimes sad for them.
Yeah.
So cute.
I went to practice and they're like, well, how was the game going? I was like, so well, we lost. And they're like, oh, wow, like, what was the score? I was like, 1-64. Okay.
At least they tried. Like
They did.
they could have.
They gave it their all, and that was what I cared
Those
about.
girls were taller than me. Some of them. I'm like, that's
I'm
not
pretty sure
cool.
they're all taller than me.
All right, so up here it said among binge drinkers, 17% have been in an alcohol-related accident. So under accident in binge, we put 0.17.
I don't know how. Oh, we need to lock the screen or something.
Then it says for non-bingers, only 9%. So that 9% is actually just going with moderate, because like we were saying, it is actually relating to alcohol-related accidents. So if you don't drink, you can't have an alcohol-related accident that would be
What
caused
other-
by
okay,
you,
so what
potentially.
about
So
other questions?
under accident for moderate, we would have 0.09. They really should have said for moderate drinkers, the accident percentage is such and such. So for abstain, the accident would be 0 because there's no accidents if they can't have an alcohol-related accident if they don't drink.
Yeah, that makes sense.
So we said that all the branches, that are red, those numbers have to add up to equal 1.
Okay.
The branches that come off of each one have to add up to equal 1. So the 2 branches for accident and none have to equal 1. So we're going to do 1 minus whatever number we have to get the none part of it.
Mm-hmm.
So that they didn't have an accident. So 1 minus 0.17 is 0.83.
Yeah. I'm starting to follow. I'm getting it, guys.
And then down here, 1 minus 0.09, 0.91. And then the none would just be 1 for this other one.
You can't do anything about 0.
So just a little note here. Each set of branches
Ooh.
adds to 1.
How do you do that so pretty? The little.
So this, I've done it for so long.
I
This
got it.
is how
Oh no.
we get other branch. So then one more thing to note is that each branch
Is this the last thing?
no,
Oh.
represents a condition. So if we multiply across the whole branch, to calculate. Okay, so we can find for the condition so that they binge and get in an accident, we're going to multiply those. So that would be 0.44 times 0.17 is going to give you 0.075. And again, I already have these multiplied, but that's all I'm doing. Binge and no accident is going to be 0.44 times 0.83. So that's going to be 0.365. Moderate accident, 0.37 times 0.09 is 0.033. Moderate no accident, 0.37 times 0.91, 0.337. Abstain in accident is 0, because it's 0.19 times 0. Then 0.19 times 1 is just going to be, just keep with the trend, 0.190, just to keep the 3 decimal places.
Good.
Okay, and I'm just going to show you down here just quickly how we actually get those. If you wanted to actually do them without just multiplying, or if you want to see it done really quickly. So the probability that they binge and they get in an accident is the probability of binge times technically the probability of an accident given that they binge, which is what this stuff is showing you. So an accident given that they binge is that 0.17. So 0.44 times the 0.17. Oh no. Is equal to the 0.075. So that would be how we would have gotten that number. Okay, but just so you see it in words, that's where this 0.075 up here came from in words.
Oh, that's easy. I'm not interested in that.
If we wanted to know the probability that there was an accident across the board, the probability of an accident would just be adding up all of the accident totals. So the 0.075, okay, and meaning the stuff that's in yellow. So the 0.075, the 0.033, and then the 0 is equal to 0.108. And just so you know, that's a joint probability. And then the probability that they binge, given that they were in an accident, is the probability of an accident intersected with binge divided by the probability of an accident, which is equal to the 0.075 divided by the 0.108, which is 0.694. So the probability that they binge, given that they were in an accident, is 0.694. So those are just a few other examples for you guys to see.
Are we almost done?
Yeah, this is the last thing.